So the first thing you always want to ask yourself when you are solving a logarithmic equation is whether or not all terms have a log or not. So in this first case, notice not all terms have a log because you have a 3 over here that is by itself. Okay, so when they don't all have a log, we need to first get a single log on one side. In this case, since the logarithms are being added, using our properties of logarithms, in order to put them back together, we multiply the expressions. And so notice as I multiply these expressions, I'll use my FOIL. So x times x would give me x squared. On the outside, x times 1 would be a positive 1x. On the inside, negative 4 times x would be a negative 4x. And on the last, negative 4 times 1 is negative 4. Now, once I have a single log on one side, then I'm ready to change it into exponential form. 4 is my base. It gets raised to a power of 3, and that is equal to x squared. I'm going to go ahead and combine these like terms, so that would be a minus 3x minus 4. And this leaves you with an algebraic equation that you now need to solve. Notice it is a quadratic, since I see an x squared term. And with quadratics, we need to first set them equal to 0. So let me simplify. 4 cubed would give me 64. And then in order to set that equal to 0, I will subtract the 64 on both sides. So at this point, I have 0 is equal to x squared minus 3x minus 68. Now, when we're solving a quadratic, always try to factor first. In this particular case, I do not have factors of negative 68 that could produce my negative 3x in the middle. So when that happens, you have to use your quadratic formula. So remember, the quadratic formula says we're going to take the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So now we'll plug in. My b value is always in front of the x term. So when I take the opposite of negative 3, I get positive 3, plus or minus the square root. When I square my b, negative 3 squared becomes 9, minus 4 times my a is always in front of the squared term. It's understood to be a 1 in this case. And my c is always the constant, so that would be a negative 68. All divided by 2 times my 1. So if I go ahead and simplify, I've got a 3 plus or minus the square root of 9. And when I multiply the negative times negative, that's going to turn into a plus. And when I do the 4 times the 68, I'm going to get a 272. And that's all divided by 2 times 1 is 2. And at this particular point, since they are asking for answers with a decimal approximation, I just went ahead and punched it into my Desmos scientific calculator. So when I did the 3 plus the square root of the 281, I got an answer of 9.8815. And when I did the 3 minus that square root of 281, I get a negative 6.8815. Now, the problem is when you try to take this negative 6 and plug it back into either place up here, it causes you to take the log of a negative number. Therefore, we have to throw that solution out because we can't take the log of a negative number. So your only solution here would be the 9.8815. Okay, so on this second problem, you'll notice that all terms have a log. So that's different from the one we just did where they did not all have a log. So we first get a single log on both sides. So once again, notice these two logarithms are being added. And when they're being added, we will multiply their terms together. So once again, I'll FOIL. X times x is x squared. On the outside, x times negative 4 is negative 4x. On the inside, 2 times x is 2x. And on my last two terms, 2 times negative 4 is a negative 8. And then, of course, the right-hand side already has a single log. So once both sides have a log, then you're ready to just set the expressions equal. And as I do this, I will also combine those like terms. So negative 4x plus 2x is a negative 2x. And then on the right-hand side, we just have x minus 1. So once again, this has led me to a quadratic equation because I see the squared term here. So in order to solve a quadratic, I have to first set it equal to 0, which means I will subtract x on both sides, and I will also add the 1. So I'm left with x squared minus 3x minus 7 is equal to 0. Again, try to factor first, but unfortunately in this case, once again, there are not factors of negative 7 that can produce that middle term of negative 3. So when that happens, we go back to our quadratic formula. And so since I wrote it up here, I won't write the formula again. I'll just go straight to plugging it in. My b in this case is negative 3. The opposite of that becomes positive 3, plus or minus the square root. When I square my b, I get a 9, minus 4 times my a, which is understood to be 1, times my c, which is a negative 7, all divided by 2 times my a again. So when I simplify, I've got a 3 plus or minus. This becomes a square root of a 9 plus a 28 divided by 2. And then the 9 plus 28 is going to, I'm just going to go ahead and do this and say that becomes a 37 under there because I'm ready to go ahead and punch it into my calculator. Okay, so when I punch this particular one out, I have an answer of 4.5413. That's going to round because of the 8. And then I have a negative 1.54, and again, that's going to round because of the 8. Unfortunately, when I look back up here, for example, right there, when I plug it in, that's going to create a negative number, and I cannot take the log of a negative number. So we're not throwing it out because itself it's a negative number. It's the fact that when you plug it in, it creates the log of a negative number. So my answer in this case will be the 4.5414 once we round up that last digit.